In today's lesson in chemistry, we're going to learn how to write formulas and name compounds that involve polyatomic ions. So you should have pulled off a periodic table that on the back side, there's your polyatomic ion chart. So let's talk about what a polyatomic ion is first. So a polyatomic ion will contain two or more elements that act as a unit. So whenever you see, for instance, if you see SO3 2 minus, that means there's one S. It's going to be covalently bonded to 3 oxygens, and there's a 2 minus charge on the whole thing. That 2 minus is not just oxygen's charge. Most of your polyatomic ions on your chart are called oxyanions. Oxy because they contain oxygens, so almost all of these have an oxygen in them. And an anion, if you'll recall, an anion would have a negative charge. The exception is ammonium, is over on the far right side of the table I gave you, and it is your positive polyatomic ion. The charge on the polyatomic ion, once again, applies to the whole group. So it's not just a charge on an element, it's for the whole polyatomic ion. So that means they have picked up like 2 extra electrons or 1 extra electron, whatever. Most of them will end in "ite" or "ate," so you've got to be super careful when you write the names and make sure I can tell if you're spelling it "ite" or "ate." So like nitrite is NO2 minus and nitrate is NO3 minus. The "ate" will always have one more oxygen than "ite." There are a couple of exceptions. OH minus is hydroxide, CN minus is cyanide, and NH4 plus is ammonia. So even though these first two end in "ide," you don't find an element on the front of your table called hydroxide or cyanide. To write the formula, simply treat the polyatomic ion as if it were a single ion by keeping it together as a unit. First, write the symbol and charge for your cation and then your anion, and then balance your charges using the crossover or crisscross method. Remember, your charges of your cation and anion have to equal 0. If you have to have more than one of the polyatomic ion, so multiples of a polyatomic ion in a formula will be indicated by placing the entire polyatomic ion in parentheses without the charge, and then write a subscript outside the parentheses to show the number of the polyatomic ion in the compound. You never ever change the subscript within the polyatomic ion. Okay, so let's practice a couple together. So we have sodium and nitrate. So the symbol for sodium is Na. And if you look at your table, hopefully you have written that this family all has a +1. Once again, this family is a 2 plus. This is a 3 plus, 3 minus, 2 minus, 1 minus. We skip this family 4A. So it's a 1 plus. Nitrate, so you look up nitrate. So nitrate is NO3 minus. So that is NO3 minus. Your charge is equal 0, so you do not have to crisscross. So your formula is Na, NO3. Make sure that is a capital N and a capital O. You would not make a lowercase o because that would be nobelium. Okay, calcium and phosphate. Calcium is Ca. Its charge is 2 plus. It's in the 2A column. Phosphate, if you look at your poly chart, phosphate should be PO4 with a 3 minus charge. Right here. The charges don't equal 0, so we're going to crisscross. So we're going to bring 3 down here, and we're going to bring 2 over here. This is saying we have to have 3 calciums for every 2 PO4s. So your formula will be written as Ca subscript 3, open parentheses, PO4, close parentheses, and you will have 2 of them. Sodium and hydroxide. Sodium is Na, is from 1A, so it's a plus charge. Hydroxide is in your first column. It is OH minus. They equal 0, so your formula is NaOH. Okay, so I want you to put this on pause for a second and then see if you can do the next few. Okay, so we have calcium and chlorate. Calcium is Ca, charge 2 plus. Chlorate, now if you'll look at your table, with you have 4 of these, You have hypochlorite, chlorite, chlorate, and perchlorate. That chlorate stands for chlorine. That is a Cl. That is not Ci. That is ClO minus, ClO2 minus, ClO3 minus, etc. So you're doing chlorate, so that is ClO3 minus. Okay, your charges don't equal 0, so you crisscross. So you're going to bring a 1 down here and a 2 down here. So that means you're going to have 1 calcium for every 2 chlorates. So your formula will be Ca, open parentheses, ClO3, close parentheses, 2. Aluminum carbonate. Aluminum is from 3A, so that is Al3 plus. Carbonate is CO3, 2 minus. Your charges do not equal 0, so you crisscross. So that says you're going to have 2 of the Als and you're going to have 3 of the CO3s. So you will write that as Al2, open parentheses, CO3, close parentheses, 3. Ammonium phosphate. So here's a case that your polyatomic ion is written first. So ammonium is NH4 plus. Phosphite is PO3, 3 minus. Charges don't equal 0, so we're going to say we have to have 3 of the NH4s and 1 of the PO3s. So your formula would be written NH4 in parentheses, and you're going to have 3 of them, and then PO3. Copper 2 hydroxide, so this one involves a transition metal. If you'll recall, the Roman numeral 2 is the charge on this particular copper ion, and so this would be Cu. That's a 2 plus from copper. Hydroxide is OH minus. They do not equal 0, so you're going to crisscross. So you're going to have 1 of your coppers to 2 of your hydroxides. So this would be Cu, open parentheses, OH, close parentheses, 2. Okay? Okay, to name polyatomic ions, you'll give the cation first, followed by the anion. Remember, if the cation is a transition metal or a metal under the stair-step, with the exception of aluminum, silver, zinc, or cadmium, you will need to determine its charge, and you'll determine it by looking at the nonmetal, and then place a Roman numeral after the metal's name. Okay, so for instance, CuSO4, so copper is one of your transition metals, so you're going to give it a Roman numeral. So we're going to look at SO3. So SO3 is a poly that is sulfite, so its charge is 2 minus. So we're going to put 2 minus up here. So that means copper's charge has to be a 2 plus. You only have 1 copper, so you would write the name of this as copper, Roman numeral 2 in parentheses, sulfite. Cu2SO3, so once again, copper is a transition metal. We have to determine its charge to give it a Roman numeral, so we're going to look at sulfite. So it's still a 2 minus, so this side is a 2 plus. However, this time we have 2 coppers, so they each must be a 1, because 2 times plus 1 is 2. So you would name this copper, Roman numeral 1 in parentheses, sulfite. AgNO3, and let me say this, you're going to know it's got a polyatomic ion in it when you look at the formula. If you see at least 3 elements, that tells you there's got to be a polyatomic ion in it. Okay, so silver is a transition metal, but its charge never changes, so you will call that silver nitrate. Okay, now put the video on pause for a second and then see if you can complete the other ones. Okay, so hopefully you realize that 10 is one of the elements. It's under the stair step. You've got to give it a charge. So you're going to look at sulfate. Sulfate is a 2 minus. You have 2 sulfates, so 2 times 2 minus is a 4 minus. So this side has to be a 4 plus, so you're going to name this 10, Roman numeral 4, IV in parentheses, sulfate. Be careful, 8 from 8. Al2SO4, aluminum is not a transition metal, so you will not give it a Roman numeral, so you will simply name this aluminum sulfate. Calcium is a 2A metal, so you do not give it a charge. It's always a 2, so it is calcium, or you don't give it a Roman numeral. Calcium sulfate. Na3PO4, Na is a 1A metal. It always has a +1 charge, so you don't have to give it a Roman numeral. So you call this guy sodium phosphate. Okay, that takes care of today's lesson. So now you will complete set 4, I think. No, it'll be set 3. Thank you.